This video will talk about the exponential parent graph. You've already done some work with exponential equations in some of your other courses and units, but now we're going to take a look specifically at the graph. So you see your HK value being plotted down here, and we can shift everything right and left. So for us, as we try to write our equations, we have to be very specific about how we do them. So HK is always going to be a point on the horizontal asymptote. That locator point will always be given to you, or at least signified, notated by a point on that asymptote. And the graph is always going to be A units above that locator point. So that's how this exponential graph differs from all of our others, in that we don't move one right from this locator point. You only move one up, or A units up. So I could drag that up, and you would see that A value is going to be whatever that is. So as we take a look, you see that A is equal to 4 because I shifted that point up 4 units. H and K are going to be given by that point on the asymptote directly below that. Now it's interesting with exponential equations because you can actually write an infinite amount of different equations for that exponential based upon that locator point, which is why we always give you one which is on that asymptote, which is notated, signified by that dotted blue line. So now as we get into these key features, the locator point is still going to be listed as HK as always. And we don't really have a special name for this. We just call it the locator because it's not a special point. It can be anywhere on that horizontal asymptote, but it is on that asymptote. Now we will write the graphing form of this equation. So you got y equals. So you have y equals, and then a times 2 to the x minus h, and then plus k afterwards. So the 2 is in parentheses. That's the base. Now, for all exponential functions that you worked with in other examples, the base is not always equal to 2. But for us, as we're working through our graphs, we're going to have that equal to 2. And the interesting thing is you can notice that your height, as it changes over time, it's a multiple of 2 every single time. So this is a height of 2. This is a height of 4. The next height would be 8, even though we can't see it all there. And you know that because the base is 2. This a value, as currently set up, is equal to 1. So you double that every time. So 1, 2, 4, 8. If you were to move backwards, this is a height of 1. This height is then 1/2. So that's always going to be the case for us with our graphing form work, and that we're going to start with a base of 2. But I hope that you remember and understand that, of course, it can be any sort of base value. Now, as we continue with the domain, you see that you have the exponent is where the x is, and the domain can be all reals. So you can put all values into the exponent, positive, negative, or fraction. It doesn't matter. So that's going to be negative infinity is less than x, which is less than positive infinity if you do the interval notation. For the range, however, that is going to be based upon whether you have a which is positive or negative. You have this horizontal asymptote. Your graph is always above it. You never touch that horizontal asymptote, so we're going to say y is greater than k, but not equal to. That is if a is greater than 0. If a is less than 0, then your range is going to be y is less than k. So if this whole graph was instead turned around, you would see that our y values are all negative then. Symmetry, there is no line of symmetry, and there is a horizontal asymptote, of course. That is going to be at y equals k. So now the final thing then would be to talk about the Moodle syntax, which would be how you type this into our digital equations. So there are a lot of ways students tend to do it, but the best, fastest way would be to put an a, then put parentheses around the 2, and then you have your caret for the exponent, and you also need parentheses around the x minus h, and then finally plus k. So the x minus h is all in the exponent of your exponential equation, and the 2 is the base. So the reason we group that together is to know that this 2 gets the exponent of x minus h and not the a.